All right. Hello. Good morning. Yeah. Hi. Hi, everybody. Good morning. Good afternoon. Actually, it's afternoon here, too. It's afternoon here. We're going to do a quick. I want to explore something. We're still doing Kotlin. I wanted to explore something. Somebody asked a great question on the internet yesterday, which is, can you imagine on the internet, good stuff, which is basically how do you do gRPC and AOT, GraalVM, right? And that got me thinking, well, gosh, maybe we should talk about that a little bit and explore a little bit. And then, likewise, I'd love to talk about the other option, which is RSocket, right? And both of which are, fine, very frequently used choices today. gRPC, obviously, a bit more than RSocket, but I think they're both worth consideration. So I thought we'd spend, maybe an hour just kind of looking at all this stuff and see where things are. But no, to the question, we're not done with Kotlin. We'll resume that. This is like a little digression. Technically, I have off tomorrow, right? So this is a one stream for the weekend, but tomorrow is still a weekend day for me, technically, just this one time. So I don't know if I'll be streaming tomorrow, but I'll try. But either way, we're gonna kick off and resume this discussion of Kotlin this week. It'll be fun. I'm looking forward to it. There are so many amazing things. We haven't even gotten to objects yet. We haven't even gotten to like classes and the basics of that kind of stuff yet. So we'll definitely cover that and see how far we can get. Like there's a lot of stuff to talk about in the Kotlin universe. But this week, today, I just want to talk about this native serialization stuff. Okay, now let's see. Share screen. All right. Let's see. Close that. Close that. So I pointed somebody. Somebody asked like what options people had for doing GraalVM native images, and I pointed them to a Git repository. By the way, today also I'm just to make things doubly difficult. I'm learning a new keyboard, a keycron. I'm actually back to this. So hi everybody. Hi everybody. Hello. Hello. Hey, I hope you have a great day as well. Hello. Did I get that? Hello. Hello. Hi. Hello. Hello. Hi, everybody. Good morning, good evening, good afternoon. I appreciate that it's probably later than usual for a lot of you. So if you can't hang around too long, I completely understand. I just had an itch. I really wanted to explore some of this stuff. And of course, as usual, most of my interesting deep dives are inspired in some way by people that are greater than I am. And one of those people, the good, the great, the amazing, Dr. Dave Sire, co-founder of Spring Boot, Spring Cloud, Spring Batch, etc. Active contributor to Spring Integration, Spring Framework, Spring AMQP, Spring Security, etc. Yeah, he's just he is like my all-time favorite. And anyway, we met. We met a few of us on the Spring team. We met last November. And we were talking about things that would be kind of interesting, and I think I brought up it'd be nice to have a story around this and native, and then other people had some ideas. And we have gRPC support in Spring Cloud Function, right? And Spring Cloud Gateway, right? So if you look at Spring Cloud Gateway, I think it's Spring Cloud Gateway gRPC. There's a blog here from 2021 where we have Spring Cloud Gateway support for gRPC. And so there's a lot of stuff that we could do. We could do a whole, and I might just do that actually. We could do a whole like deep dive into gRPC and Spring Cloud Gateway and gRPC, Spring Cloud Function, is it? gRPC. Let's see. So function now allows you to invoke a function via gRPC as well. So there's a deep dive there that's worth doing. There's a lot of stuff that we could do. But today, friends, we're just going to start with the absolute basics and kind of talk about what you shouldn't do today, right? So I don't know how many of you have been using Spring for long enough to remember this, but there was a time when it's still there. It's probably still there. There was a number of different exporters, service exporters. So if you used Spring in 1.0, in the bad old days 20 years ago, there was a 1.0 and later set of exporters, service exporters that would basically let you take a bean, a Pojo. And by the way, just contextualize this, right? Think about where we're coming from with this. At the time, the only ways that people knew about it to create RPC services conveniently were RMI, right, which is part of the JDK. And then something like XMLRPC. If you wanted to go like way off the deep end, you could use EJB. But basically, it was all painful. And so with RMI, the other thing is it didn't really have a lot of. It was very fragile because your payloads were tied to Java objects and they were tied to Java serialization. And if you had one client using a different version of a type than the service, then you might have an issue with serialization, right? And so there's no natural way to sort of account for that. So, and the other thing is that you have to create all these like objects that implemented certain interfaces and threw remote exceptions and all this, and it became very difficult to create a service. You were very quickly mired in the business of networking as opposed to thinking about your service interface, the interface that you're exporting to the open web. And so compare that to .NET, right? .NET 1.0 came out in like 2001 or 2002, and they had an attribute. They had those are what they call annotations, as they're called attributes in .NET. And so you could take an object in C#, add an attribute, and suddenly that attribute was now a service that could respond to serialized message calls or method invocations over the wire, right? Just one simple attribute, and you got the job done, right? It's amazing. So I think in the Java community, we were looking for something that would give us that. Spring came along and said, look, Java doesn't have annotations yet, right? Remember, Spring came out years before annotations did. So they created a way to describe, here's a POJO, here's a Java object with an interface, right? It didn't have to have an interface, but here's a Java object that had public methods. You can automatically use one of our service exporters to take that object and export it as a service. And so you got things like the RMI service exporter. You got Hessian and Burlap. Does anybody here remember Hessian exporter? Hessian, was it resin, Hessian, okay, resin, yeah. So this is a serialization protocol from at least 20 years ago. Binary serialization protocol with support for RPC, provides cross-language binary object serialization with efficiencies better than Java I/O serialization, which that was a big deal back then. But these days we know there are a lot of things that are faster than Java I/O serialization. So here's how the low-level API looked, right? You'd create a byte array output stream, you use a Hessian to output, write the message, serialize, and then close the stream and get the byte array, right? Deserialization works in the other way. And then that was Hessian. This is binary. There's another thing called burlap, right? Which was XML. So or text. So, oh, my keyboard. Burlap, resin, exporter, okay? Yes. Oh, this is, wow. I've done really, this surprises me. I can't believe they have this content. This is, I covered this in my first few books, 15 years ago, but okay. So here's Hessian, right? Yeah, here's how that would look today. You can actually, I think you could probably still use this stuff today. I don't know why you couldn't, unless we took those out of the framework. I don't know. Maybe they're still there. Who knows? I haven't used them in years. But here's the remote exporter. So you create a Hessian service exporter. You create the service, right? Set the service interface. So this is the delegate, right? The actual thing, the proxies. And then you can create and then that will actually create a endpoint under / booking. So you make a call to that endpoint, and it'll do content negotiation and conduct data over the wire using this protocol. Okay. So here's the client. Here is Hessian proxy factory bean. You're creating a service URL, creating an interface, and you create this, and Spring will give you an object that implements this type that you can inject, that when you invoke methods will actually make a call to this endpoint, okay, using that protocol. So that's Hessian. What about burlap? This is burlap, right? Okay, so same idea. You use the remote exporter, and the client side you use the burlap proxy factory bean. Same basic approach. I guess this article doesn't really talk about the differences there, right? Burlap is another lightweight protocol from Caucho based on XML, right? Exactly. So Hessian was like binary, Burlap was XML, but basically both of them I wouldn't use either one of them today at all, right? And in fact, even 10, 15 years ago, it was starting to become very clear that there were other approaches to doing serialization. So you had RMI, you had Hessian, you had Burlap. What was it? Oh, Spring also had something called the HTTP service invoker, or HTTP service exporter, right? And what that was kind of the best of both worlds. That was RMI payloads, so you'd serialize Java objects using Java serialization, just like with RMI, but the data was being conducted over HTTP. So you could punch through the firewall of most enterprisey organizations and speak HTTP, but it still had some of the drawbacks of Java serialization. Not very fast, definitely not very secure, and definitely fragile if you have different versions of client and services, right? But it did get around some of the limitations of just pure play RMI, and so I quite liked it. If you had a web server up and running, you could use HTTP services, Invoker, and so I quite like that as well. But those are the four that I remember Spring had. You could give it an interface, you could use a service exporter, and you could get an RMI service, an HTTP Invoker service, a Hessian service, or a Bird app service. And then, a long time ago, very long time ago, let me see if I, what the, find me later, thank you. Long time ago, I don't need, let me see, Josh Long, my keyboard, help. New keyboard, still trying to get things figured out here. Okay, so service. Let's see. Exporters. Okay, so it's not there. Let me see. I love Hammer Spoon. Yeah, this is good stuff right there. I used to use oh gosh, what did I use? Shift It was I used to use Shift It, and then they just stopped working, and I forget what it was. I had shown my buddy Matt Rabel Shift It, and he used it for a while, and then he and I both hit a point where it just stopped working correctly. I forget what the issue was. It's probably fixed. I don't know. So then he had gotten it working with Hammer Spoon. He helped me figure that out. So Hammer Spoon. Oh, my keys. I can't type. I'm using this new Keychron. Okay, Hammer Spoon. Oh. Content. Holy good God. Okay. Okay. Shifted that. So this is February 2022, last year basically. So here's the blog where I talked about what he showed me and all the stuff that I did to make it work in my configuration. He was nice enough to even use. He even wrote a init.lua, and that basically did what we did before. So if you're used to Shift It, the same basic key commands, Command Shift left, right, up, down, etc. I love this as a window management solution. Okay, so repositories, exporter. There you go. This one. This is from 2011. So this is, well, at least 11 years, almost 12. Not almost, but closer to, getting on towards 12. And the idea was that this added a bunch of new service exporters to Spring, right? And so this is Spring 3.0. It's a little old. So basically, I created a bunch of new service exporters for, and integrated a bunch of new, serialization technologies, including RPC technologies like JBoss remoting, message pack, thrift, Avro. I don't think we got to Netty. So there's a few of them there, right? These are like in the same that we had OXM, object XML marshalers. I created OBM, object binary marshalers, right? And there was just a bunch of implementations for different protocols. I don't know how much we got in there, but I also demonstrated a bunch of, like, let's see, Avro RPC. There's that. Org Spring Framework. So remoting, Avro, what is JBR? I wonder what that is. Oh, JBoss remoting, message pack, thrift. So you could use these in the same way. You create a remoter, point it to an interface, and it'll create a proxy that then speaks that protocol, right? Source main Java remoting. And there's marshalling message converter. Is this for, what is this? I'm not even sure what that is for. And then there's converters. Again, I'm not sure. I guess that's just a new interface that I created that extends the abstract to HTTP message converter. So there you go, basic stuff. But basically, I love the idea of being able to transparently create a service from my types. I like RPC. That said, there's a lot of problems, right? Like a lot of problems with RPC that you got to be aware of, right? And I think that's why we could even check. I'm not even sure. So Spring Framework 6 GitHub. Okay, let's see if there's the RMI. Is there Hessian stuff in here? I wonder. I don't even know. Hessian. shorter. How is that matching? No. Yeah, I don't even know if it's in here anymore, right? The Hessian burlap stuff. It would be very surprising. I don't know if anybody's using it. I doubt it. The HTTP service invoker. What about invoker? It's probably going to be a lot of invokers. Did they remove Hessian burlap from the Spring? Because remember, we saw burlap is not even supported anymore. Is this it? This is 3.2. Okay. Doc current reference. Okay. Yeah. No idea. Yeah, I don't think it's there anymore, right? So the point is that stuff is gone. I wouldn't use this kind of approach to RPC. What we need is something that gives you RPC while also letting you account for some of the realities of distributed systems, right? Things like the fact that the system is fallible, the network is not always super fast, that we have multiple clients, not just Java to Java, that we have to handle different versions of payloads, etc. Right? And so one approach to that in the modern world is gRPC, right? Which is a superset of Google Protocol Buffs. So Google released Google Protocol Buffs first. Google Protocol Buffs are, they're a way to serialize objects, right? And there's a very simple schema style that you can use for that. And then that you could use for anything. I could use that just to write data to my grid if I wanted to. I don't have to do networking services. I could just write to disk using Google Protocol Buffs. And Google Protocol Buffs are designed explicitly to account for version incompatibility. I got a client that speaks X, and I've got a service that speaks X+1. I need them to interoperate as best as possible. And as long as you haven't changed anything or broken, like as long as you haven't changed something that was already there, or at least not changed its ordering, then things should be okay with GRP with Google Protocol Buffs, right? It's a binary encoding, so it's very fast as well. It's not like XML or some sort of text protocol. So I like gRPC. It certainly has its benefits. It does code generation, which I do not love. Okay, it requires code generation. So anyway, let's just look at an example, a very simple example, and it's not my example. Remember, I don't do useful things here, friends. All I do is I keep track of other people who are doing useful things. And then in this case, like I said, it's the good, the great, the amazing Dr. Dave Sire who put this together back in December of last year, which feels weird to say. It's hard to believe that December is already, actually, this is 3 months ago. That's ridiculous. That feels like yesterday. I was in the room when he built it. That's 3 months ago he built this. So today's the 12th of March. This was December 12th. So by the way, I don't know about you all, by the way. Another thing that threw off my timing today is daylight savings time, right? It's at least here in the States, right? So we get more sunlight today, right? We have an extra hour of sun, which is great because I hate the dark, cold months with a passion, right? But anyway, so this is 3 months ago. I don't know, 3 months and an hour. And so we're going to just look through his example. It's using Maven. I don't know how to do it with Gradle yet. Maybe someone out there wants to help me. We could do another stream on that. We're not going to have time to do it today. It's just using Maven. So let's check it out. I think I've already got it cloned here, right? So there's this native gRPC get reset hard. Okay. Okay, there's this. Trust me, as an EU citizen, it also threw me off, given the number of USA content creators I follow. Oh yeah, the switch to daily savings. We should get. I mean, I'm sure I don't need to tell any of you this, but we desperately need to get rid of daily savings time. It is just nothing but a headache. The only reason I like it is because it means I can appreciate longer days. You don't know the sweet without the sour, right? Those cold, dark months make me appreciate spring even more. Not that I needed any extra reasons, but yeah, I'm super happy. Okay, so let's see. Idea. Oh, like I said, friends, I'm still learning how to type on this thing. Okay, pom.xml. Okay. Now is the time. Okay, anyway, my fingers feel all weird. Let's see. So this example is a clone of the canonical native gRPC example from Yidongnan. That's this gentleman, Michael Zhang, I think. And so, here's the example from here, right? Oh, it's got it. Oh, this is the sample that he's got in the starter. So this is a starter that you can use. It's not our starter. It's not the Spring Team starter. But it's very widely used and respected and quite nice, right? And remember we talked about the other day, if you want to really extend your project's reach, English will get you, half the world. Not everybody speaks English, but they can read it, and a lot of people understand it for the documentation. The other half speaks Chinese. So there's still a lot of people that we could help if we had more languages, of course. But for tech, these two languages will get you a lot. They'll get you huge chunks of the planet. Okay, so this is a starter. Again, very widely used. It's been around for a long time. Well supported, well integrated. You can see the latest change was 2 days ago, so people are actively working on it. Well, this is a bot, but just trust me, it's being used and updated all the time. 2 months ago, last year. Okay, so 3 days ago, here's this, the dependencies, blah, blah, blah. And it has a sample. And so that Dave, bless him, he took that sample and he made it work with GraalVM. So we're just going to look at the sample. The reason I don't know how to do this in Gradle is because there's some goofiness with the build, because it does compile time code generation. And I'm sure there's a natural way to do this with Gradle. I'm just not brave enough to try it right now with a limited budget of time on a live stream without some ideas as to where I would even begin. So here's the basics, okay? He brought in the Spring Boot starter, right? Which is just the minimal, it doesn't have any particularly useful auto configs. It's just the common stuff, plus some very common types. He brought in the gRPC Spring Boot starter from that project. He brought in 2.14.0. Notice that he excludes gRPC Netty shaded so that he can bring in a different version of gRPC Netty, in particular this one, 1.51.0. Another way you might do this is to do the dependency management bill of materials for that project. Just define that in the dependency management section here, and then point it to 1.51.0, and that'll automatically, and then exclude that, and then bring this in, right? And so you wouldn't have to specify the version, and if you needed any of the other dependencies, those would come in as well. Javax annotation API, because of course that's new in Spring Boot. This thing still supports Spring Boot 2.x. So be aware that it works on both 3.0 and 2.x, but it's not necessarily guaranteed to be a smooth out of the box story for Spring Boot 3 use cases. The next thing we need to do is we need to do some code generation, like I said, and what that's doing is it's actually going to look in your source main proto folder for a service definition. And so here's the service. It's called simple. It's got an endpoint called say hello that takes a request and returns a reply. The payload, the structure of those payloads is hello request, which has a field called name. That's the first item. It's like a struct. You're defining the memory layout, the layout of the payload itself, right? And so as long as this stays at position 1, for all the clients and all the services, you can still talk, even if you've added a new field at position 2, right? So you're describing where, the offsets of each of these types, right? It can seek to this field at this index and it'll work. And it's going to return a reply and so on. So very hello world, basically. And to make this compiler, to make the code generator work, because remember, there's gRPC and there are code generators for a number of different languages. And so we're using Java, but you can, the nice thing about gRPC is that it's easy enough to take this service definition, this protobuf definition, and code generate a Go client or a Python client or a Node.js JavaScript client, right? So that you could all talk to the same endpoint, no matter what language you're coming at it from. Hi, hello, hi. So yeah, this is very convenient, and you have the ability to specify options. In this case, this is only for the Java client generator, right? It says, okay, we want to have multiple files, great. We want to have a Java package, great. So we want that to line up with com example demo proto. So it's going to create a new package under here called proto in the generated sources folder. It's going to create a new class called hello world proto that contains the definition of our RPC interface. Okay, so that's the basic definition. You can share this definition between different languages. That's the important part. And as long as you've got a compiler plugin that'll generate the Java client for you, you can interoperate. So that's what all this craziness is. We're adding an extension to discover the operating system. We're setting up a plugin. And what is this doing? Oh, this is configuring the Graalvm native image compiler. So I guess you don't need that just yet, but it's configuring some things that make it easier to understand what's happening and to make sure it works. I guess that is something that Dave ran into. This is the Spring Boot plugin that comes out of the box. And here's where the gRPC rubber meets the road, right? Here we're using the protobuf Maven plugin. We're using so protoc is a native binary. It's a command line tool. It's the proto compiler, protoc, like Java and Javac, and it is compiled for each operating system, obviously. So you need to tell it which operating system version of protoc to use. In order to do that, we're saying we want this artifact with this version, this qualifier, and this operating system. And that operating system is through an attribute that's created in the project thanks to this. Okay, so that exports the keys and the properties that we can then use to refer to the current operating system on which this Java code is running. In my case, I'm running on an Apple M1. So if you're wondering about whether this works on the latest and greatest, yes, it does. It does. gRPC Java, plugin artifact, protoc artifact, same basic trick here. We're using the gRPC Java compiler with that qualifier and so on. The architecture, I don't know if it matters, but it looks like it's operating system detected classifier, and it's the protoc binary is native. So I wonder if I guess Rosetta could do the job. It's just the point is it's working. Like Rosetta doesn't always do the job perfectly. So okay, let's see here, friends. I think that's it. It's not particularly special or whatever, but it works. So here's the actual service, the GRP service. We don't have that interface there, so let's go ahead and generate that. That was this question. Hey, Deshaun, good to see you, buddy. Okay, so let's see here. Okay, let that run. Oh, you can see what it printed out. There's the plugin. OS detected name OS detected Arch is Arch 64, 13.1, 13.1 OS Arch 64. So good. There's like all that stuff there you can use. So I just compiled it. Let's see if this is thinking better about what we're doing here. Reload from disk. Okay. And can we run this thing? What is happening? Where's my proto? Source target. Generated sources. Protobuf. gRPC Java. Proto source. Hello reply. Wait, did it not compile that? I guess we can just do Maven Spring Boot run. That'll. Okay, let's see here. Source target generated sources. Classes, com, proto. There it is. Okay, so the types exist. What about this? Okay, well, there's that little fun class path like reconciliation problem, which is, I didn't have this before. I did a very basic dry run before we got on the screen here, and I didn't have this issue. So it's always fun to fail in new and marvelous ways. But you can see basically the Maven plugin did its work. I was able to generate this message, and I have a builder, and then that is what Dr. Sire is using in this example here, which I think again he forked and improved upon from the built one, the one that was built in. Let's see here. Maybe I could close this and then re-import it. Set source and I didn't have to do that before. Let me try one thing before I do that. If I have to do that, I will. But I think I did something differently this time. So RMRF idea. Yeah. Whoop, sorry, you said that, and you said that, and again, I think that'll. I mean, I know how to do that. I'll do that if I need to, but I don't think I need to. Let me just restart the build. There you go. I had to just re-import it. So if I re-imported it with the code already generated, then for some reason Tomcat is happy. Sorry, IntelliJ is happy. Okay. So there's the generated code. Oh wow! Did you see that? I hit Command Q on the type here. This is generated, and it didn't take me to the generated Java code. It took me to the protobuf definition. Oh, chef's kiss. That's dope. Good stuff. Okay, so basically this is a type, and this type doesn't have to be public. It was public when I cloned it, right? But it doesn't have to be. It can be, and this is just a stereotype annotation. It in turn is @serviced. So basically, it's just, you've seen that before. And here's the definition. We're saying when the request comes in, we can produce a response. And you're saying, okay, we're using a stream observer to provide the responses, and we can say, okay, on next, here's a response. Hello, reply, new builder, set the message, blah blah blah. Then we do on completed, and all that kind of stuff. When it's uncompleted, that is effectively how we send the response. So this doesn't feel very like RPC-y, right? It doesn't feel like I'm actually taking a Java object that I would write in my unit test and then making it a network service, right? And it definitely feels like I'm writing code in terms of gRPC instead of in terms of my domain language, my domain model, which is one of the reasons why I don't love gRPC all that much. I mean, it works, it's fine. I don't love it. So let's see here. So that's let's just run it first of all. Let's see if that gets us what we're expecting. Okay, run this. Okay, it's running, and then again, you'll need another tool called GRPC curl or GRP curl, because I don't want to have two C's, right? So here's the incantation you can use to just test that endpoint. Works fine. Okay. There's that. So I'm making this call with this payload, JSON, payload. Want plain text, sending it to this endpoint, to this URI and this endpoint, or that service, and I'm getting that response back. Okay, it's fine, right? The real magic trick here is that the good Dr. Sire made it work for native. So p native compile. Let me stop this right over here. Okay, and this takes. Ooh, what happened there? Oh, port is already in use. It was running the tests. Let me run that again. Okay, let that run. This takes, I don't know, 30 seconds, 40 seconds to get this very trivial thing going. It's not a particularly demanding service, so it doesn't take all that much time to do. But you've seen me do native compiles a number of times. The only I think Dr. Sire worked with the upstream projects to get most of this stuff, or he found issues that talked to the things he's needed, and he upvoted those. And basically, most of the stuff you need to make this work in a GraalVM native image is already done for you, right? The only thing I think he had to do manually is register the IONetty buffer, abstract buff, byte buff allocator, and register a hint for that. This could very well be in the Oracle GraalVM repository metadata repository, the metadata repository. And I don't know why it isn't yet, but I tried commenting this out because this example is from January and it was still required. So it broke if I didn't have this. So he's just registering that runtime hint with this one line. Okay, let's see. Good. It's built 50 seconds. Okay, whatever. So target demo. Enter. No. There you go. So 51 milliseconds, 32 milliseconds, 34 milliseconds, 36. I don't know why it starts up slow, and then the first time it starts up slower because the operating system has to load a few things. But every subsequent run, it's about 30 something milliseconds, right? And now I've got a network server, and just as before, I can use my GRP curl to get the response. So let's try that. No, don't have it. Where did I put it? Here. Okay, same response. Okay, so that's gRPC. We will definitely do a deeper dive in all this other stuff. Like we're going to look at Spring Cloud Function. We'll look at Spring Cloud Gateway. Just not today, because I want to compare this Hello World to RSocket. That's all. And I haven't even tried that, but last I checked, last year, RSocket and GraalVM also worked well together. But we still have work to do. Now, maybe if we have time today, we've got like, I don't know, another 20 minutes-ish. We met in Bangalore. Oh, that is so cool. I miss Bangalore. I miss, Bengaluru. Yeah, I miss Bengaluru. Like, I have a special spot in my heart and my tummy for your beautiful, beautiful garden city. Okay, so native gRPC, that's this. Let's build a service. Now, again, with the gRPC stuff, the complexity is in the build, right? You're not really building all that much code. You build the service, and then the build does most of the work, right? And you just write this. You just extend the implementation base that it gives you and override the methods that it provides with your own business logic, and that's how that gets marked as a service that gets exported to handle RPC invocations. With RSocket, there's no build time complexity. It all happens at runtime, and it can happen it's very fast, and it's also language agnostic. So I can use Python, I can use Ruby, I can use C or whatever to talk to RSocket endpoints. I don't have to define explicit service definitions like this either. It just kind of works. So let's go ahead and start that up with a start.spring.io. Okay. Oh, my friend. I'm sorry, friends. I only just now, as I'm talking to you, I just saw a tweet pop up from Mary Grigleski. Oh. Her mother passed away. And so she tweeted, oh, that's the worst feeling. That's the worst. Oh, yeah. If you know Mary Grigleski, you should. Oh, wow. Yeah. Poor thing. That's the worst feeling. Yeah. When she got to spend some time with her mother, she said she spent the last few weeks with her mother in I think Hong Kong. I don't remember exactly. I think it's Hong Kong, but man, that's a downer. Okay, let's well wishes, thoughts, hugs, send her all the love in the world that we can. But okay, I'll revisit that. Let me get on with this because that's so sad though. God, that's sad. There's no that's gonna hurt. I mean, I'm sure a lot of you know it. Once you've lost a parent, that's a huge chunk of your heart that just doesn't come back. Period. It's not like It's not like they say the pain does diminish, but it hurts forever. It's just still every day like, I'm missing something in my life. All right, so RSocket service. We're just gonna call it service. You can do gRPC calls within IntelliJ. Nice. Let's try that out. Okay, wait. Wait. I don't even know how. Do I need to have a plugin installed? gRPC bundled, yeah. RPC's inside endpoints tool window. Okay, so cancel this. Now, what is the endpoints? Endpoints. Oh, look at that. I've got this. Jump to source. Oh, come back. So hello request, HTTP client. That's for jump to source. I don't want to jump to source. Yeah, I'm sure there's a way, but I don't know how to do it though. Simple. What? No, I want the just. Okay, well, anyway, yeah, I guess there's a way to do it. I don't know how to do it, but I always like gRPC curl, GRP curl, you know what I'm saying? gRPC URL, maybe that's what they're trying to tell me. Okay, so here we're going to use RSocket. Now, RSocket is a reactive, no, and also with the HTTP file, and just put your call there, I think. Okay, we'll revisit. We're going to definitely do a deep dive on gRPC. I just wanted to get this RSocket demo out of the way. RSocket, to use RSocket effectively, you need reactive programming. So that's the first thing. You can do non-reactive, but the endpoints themselves are best expressed with RSocket. That's when you get the full benefit of this. It has several benefits, not the least of which is that it's a platform and language agnostic, just like gRPC. It doesn't require a schema file. It's reactive. It's got multiplexing. It's got request response. It's got bidirectional. It's got streaming, multiplex conversations back and forth, and so on. It's even got server-side push of a sort. So it can do a lot more than you can do with WebSockets or with HTTP. It's a very fast binary protocol, just like gRPC. And also the serialization itself is completely up to you. Like you can do JSON, you can do XML, you can do Hessian, you can do burlap. Like, I mean, there's some defaults there, and I think by default you get let me get rid of all this. Okay. Hello. Wow. Did you see that? I hit enter. You can hear it, right? My keyboard is as I pound my keyboard, you can hear it from like other parts of the planet. Forget about the live stream. It's just so loud. So I hit the keyboard like a week ago, and then finally I get service.zip. Something's going on there. I don't know. Zap Josh, regards from Portugal. Hello. Hi from San Francisco. Okay. Open this up. Okay. And service. So again, pretty trivial. We're going to describe our domain in terms of our domain instead of a schema file. Okay. And I'm going to create a @controller. Okay. Customer controller. Okay, and then we're going to create a message mapping endpoint. So what's a good example here? Mono of customer. Oh man, this keyboard, I'm telling you, this is going to be very painful for like a year. Oh, come on. by ID destination variable. Okay, integer ID, mono.just new customer ID, and then it'll be whatever world. Okay, Bob. All right. Oh, that was painful. And unlike with HTTP, you have to opt in. So RSocket server port, oh god, equals 90, whatever. It could, whatever protocol you want. Is that gonna do it? Let's see if that does it. Oh, I have to create an endpoint name, don't I? Yeah. There's already something that they. Okay, I want 91. And also, I have to create the endpoint name, I guess. So I'm going to call this hello dot ID or customer's ID, right? There's that. Oh, this oh god. All right, here we go. Okay, it's up and running. Whew. I only had to. It only took like 5 million corrections and keystrokes to get working. So there's my RPC, my RSocket network service, and I don't know if I still have it installed. What you would do is Maki-san, Toshiaki Maki, has an amazing CLI called RSC. Okay, and it's just brilliant. So it's RSC. I haven't installed it recently. Let me see if he's got the correct version. Homebrew. Okay, looks like it. Yep, there it is. Well, at least I hope so. Maki-san top RC. Okay, so brew install. I am x64 architecture is required for this software. Womp womp womp. Okay, there's a way around this. You can just use the Java jar. Okay. So what's the easiest way? Is there a distribution? Where's the release? Via Homebrew, Windows, Mac Linux. Where's the jar? Releases. Here we go. So here's the jar. And I just want the jar from June 27, 2021. Use this. So you can use that command line utility. If you're on an M1, you need to use Java -jar, which is fine. We can do that, right? We have this technology. And then we want to call our endpoint. Okay. What's an example? Simple hello world. RSC route. I love this guy. I love Toshiaki Maki-san. I like Maki-san. Like one of the smartest people in the world, and just when you think you finally caught up with him, just when you think you finally understand what he's doing, he's already doing something else. I love watching his work. Let's see here. What's just a simple example? Here we go. Route equals hello, and then let's just try that route like that. Hello, or sorry, customers dot to, because scheme is no. Oh, okay. What's this? Oh, it's the host import, right? Yeah, so it's TCP localhost 9191, right? So TCP localhost 9191. These work. Okay, almost there. Found multiple. Okay, so I want to do request response. So by default, you get stream, right? You get multiple values back. Okay, but I need to specify the mode. And how do I do that here? Log data, set up metadata, request response. There you go, request. So it's dash dash request. So let's just try that then. Multiple arguments for options arguments, but you only ask for one. Oh wait, what? It's the keyboard plus my, oh boy. Request is not a configured option. Okay. Request. Oh, my friends. Oh. Keyboard away. But you only ask for one. I mean, I could just return a stream. Let's just try that. Okay, I'll just return a reactive stream, which is what it wants by default. It'll be a lot easier than screwing around with the CLI. Oh my God. Okay, here we go. Here we go. I'm going to try this again. There's even a big red, like the enter button is painted red. It's like, just hit that and you'll be fine. And somehow I managed to hit everything but. And multiple argument for options. Okay, JavaS jar route. I'm missing something. Request customers in .1, right? Customers .2. Okay, destination variable. Wait, let's just try customers by itself. Like, am I doing something very obviously wrong? That's the issue. Java, okay. Invocation target. Value set args, RC command line runner. Let's just look at the code for that. But only, you asked for only one. I don't get route customers. RC. Am I doing it? What stream dash dash stream dash dash route equals. Okay. Source. Well, I'm like baffled as to what I could be doing wrong here. Route uppercase. Data equals food. There's no data. But in this case, what I was trying to say earlier is that it's much easier to create a client, right? So let's just do that the old-fashioned way. RSocket. Okay, client. UAO client. .zip. And create a bean of type RSocket requester. Gosh. Oh my God. Okay, inject the builder. TCP is localhost 9191. The route is customers. Although even there, do I have to specify that each time? I don't think I do. I can just build this. Okay, RSocket requester. No, build. What do I need here? RSocket client. guess. Okay. This has changed as well. What did I just do? What am I doing here? Okay, a thin wrapper around. So you want, okay, return the underlying RSocket client used to make requests with. So this is I want the RSocket client. Is that the new thing? Okay, good. So now, mean okay, there's that. And we're going to inject the RSocket client, I suppose. So there's that. Connect, we want to do a request response. Okay. What am I looking for here? The payload. Payload. Fire and forget, metadata push, request response. What? What is this payload business? So I want the RSocket requester. Okay, so let's see. What am I doing? How do I get a RSocket request out of this thing? I feel like that used to be a thing you would do. And now I'm not so sure. Yeah, so before you'd say like, given the client, but request response, I want to specify the route, right? Like, how do I specify the route? Something is different here. I need a pointer to the RSocket requester. Let's see how to build that. How to build a RSocket requester. Okay, build up. Oh. See, it's specifying, is the requester just a builder now? Is that what deprecated in favor of transport? Connect, transport. It should just be the default, right? I don't want to do anything special there. Deprecated. Well, let's go here again. See, this is 2021. I really think things are going to be different compared to, okay, so request response with RSocket and Spring Boot. So create a controller, great, message mapping, just like I did. Client, I create the RSocket requester, I inject that. Route, how do I get the RSocket requester? That's the real question. Where's the definition? Okay, publisher, RSocket requester, server, client on the client side, okay. Exception handling. Yeah, I should check out ChatGPT. Actually, I should just check out my own code, but I'm worried that it's going to be out of date. That's the thing. That's why I'm like a little confused. If I go to Spring Tips, you know, I've done this a million times. RSocket. Okay, RSocket. Here we go. I did a crazy video on this. Well, this is 5 years old already? No, there's a newer one. Repositories. RSocket. Let's see, RSocket Spring Messaging. 2022. Greetings client, let's just try that. Source, main, Java. Greetings client. RSocket requester, connect TCP, block. You just call block and get an RSocket requester. Can I do that now? does this give me? It gives me an RSocket requester. Actually, that might be all I need. Okay. So can I do that? So I've got a RSocket requester. Inject client.rsocket. Ah, okay. Route is customers. And then the body, the data, is, there's no data, but I want the data that I want to get the response back. So send, want to avoid, stream, retrieve flux, there you go, retrieve flux of type customer. We don't have the customer, so we copy and paste all this from here. Okay, paste. So everything that could go wrong has. So that's good. This is where we got all the bugs out of our system. Two. Oh, it's not blocking. Of course, it's not blocking. There we go. That was painful, but it worked. I was able to get the response by using the, so I created the RSocket requester. That's the client. That's like the reactive web client. And it's got the same basic approach. You use the RSocket requester .builder, just like you use web client .builder. You inject the RSocket requester, and then you specify the route, and then specify whether you expect a single response or a stream of results, or whether you expect bidirectional communication or whatever. Not bad, huh? So you got all this stuff. Very, very convenient. Now, does this turn into a native image? Hold on. Okay, so let's see if we can turn this into a native image. Go over here to our service. Is this the service? Yes, it is. And want to stop it. Go into the console here, and we'll say Gradle native compile. Oh, what did I do? Oh, native compile. Or not. Oh, I'm not. I didn't configure GraalVM. So start .spring.io. GraalVM. Copy and paste this to my build. Here we are. Paste. That's the service. Okay. Why now? Okay. And now what? Native compile. Oh, painful. This keyboard, man. Wow. I think I would have still lost a lot of time just trying to remember what the latest and greatest flavor of RSocket requester looks like. But this keyboard has definitely not helped things. It's been the challenge of my day. It's a nice keyboard. Like it's upside down, but it's beautiful, gorgeous. Like it's Ergo too, so I can actually type. My other keyboard is bigger, and I had more like a boat. It took up more space. So even though this has a cable attached to it, whereas the other one was wireless, this one feels, it just gives me more of my desk space back. It's also pretty comfortable. I just have to like get used to typing with it. It's so small. So like before, I could kind of place my hand somewhere on the keyboard, and I would probably hit the right key. And if I didn't, I would just move over a little bit and it'd be fine. But with this, you got to be on the right key. You need to look and make sure your hands are squat where they should be. Okay, so cd build generated. Okay. Okay, there it is. So what about our, let's go run the client again, just to make sure that's working. Okay, take 2. We're gonna run the client as a Java client, but again, who cares? Okay, so basically the client works. Now let's see if we can compile the client here. And, same basic technique. Native compile. Nope. Got to do the same thing for the build. Did I not do that already? Build that Gradle here. Here. Okay. So take 3. Let that do its thing. And it's worth noting that if we get this working, like, because I'm a little greedy, I want to do one more thing and then we'll call it a day. But there's one more thing, which is in Spring Framework 6, we now have support for interface-based declarative RSocket clients. So you neither need code generation, nor do you need to write code. Like I wrote, it wasn't a lot of code, but I had to write this code myself. Right? Imagine if you just had an interface and suddenly you could use that as and so you're kind of back where we started, which is you get the sort of convenience of service exporters from Spring Framework 1.0 with the benefits of a protocol that's designed for the open web, that's designed to be language and framework agnostic and protocol agnostic without requiring you to use only Google Protocol Bus, and while supporting the things you need to build more robust services like reactive back pressure and so on. Okay, so here's the client. Build native compile. What just happened there? Oh, I need to serialize on both sides, I reckon. I need to register this type for serialization. So register for reflective binding class. And I bet this is going to be a problem on the other side too. Okay. Okay, so Gradle, native compile. Let's do it one more time. And I wonder if we can do this one at the same time. Okay. Now, the question is, do I have enough CPU? Well, welcome to the stream. RSocket is a protocol that was created by Netflix and then Facebook. So people that were at Netflix went to Facebook, and there they moved it forward. It was built after gRPC was built. It was built after certainly RMI and EJB and all that other stuff. So it was meant to get around some of the limitations of straight HTTP2 and straight gRPC and so on, right? It's a binary protocol. It's reactive on the wire. So you can actually perpetuate back pressure from one service to another, right? Whereas with HTTP doesn't have back pressure. Once that, if I speak HTTP from curl and I talk to an HTTP service, there is no way for the service to propagate back pressure to the client, which might then propagate it to another database or whatever. But with RSocket, you can have chains of back pressure. It's just an amazing technology. It also establishes a stateful socket. So when a client connects to a service, it stays connected. And that means that if you have a service that you want to speak RSocket, it only needs to connect once. And in fact, the service can connect to the client first. It doesn't have to be the client connects to the service. What that means is that you can put a black box service in production. You can have no firewall openings, right? You can send data out from the service to the client, and then open up a socket, and then they can communicate bidirectionally because they have an open socket. But yeah, it's just amazing. There is it's a persistent TCP connection to the transport layer, which brings us to the next point, which is how do you do load balancing? And that story isn't as good as it should be, but it's getting there. So RSocket, GitHub, they have we worked, the Spring Cloud Gateway team and the RSocket team and others, we all work together. And I'm not sure where this is. This is where it might be useful to get, oh, by the way, there's a RSocket RPC implementation. Nice. What is the RSocket Foundation, is it? Where do they put it? RSocket. Load balancing. What was it? The Reactive Foundation. Reactive Foundation. GitHub. I think there we go. Stuff. Okay. TSC. RSocket Foundation. I don't remember where we stashed this stuff. Okay. Linux Foundation. I can't even find it. Yeah, so originally, these leaders will include Alibaba, Facebook, Netify, Pivotal, right? So the where did the project go? Where is the RSocket gateway? Yeah, there's a project out there. I don't know where it is, but I've got to find it. But I need to get Ole Dukuka to come on the show and help explain it for us because I am at a loss at the moment. Native build, native compile service. Okay, 54 milliseconds. Great. What about this one? Build native compile client. Hey, there we go. It worked. So you've got your native client running in 28 milliseconds. You got your native service in 58 milliseconds. We looked at native gRPC as well. These are both as quick. gRPC and RSocket are both blazing fast. You're not going to get better performance over the wire for services. Our gRPC has the distinction of being a protocol that you use a lot if you're using Kubernetes, low-level APIs. I helped contribute the GraalVM native image hints for the Kubernetes Java client. So you can imagine writing a Kubernetes controller with Spring Boot that compiles to a native image that starts up in tens of milliseconds, that uses gRPC to talk to other services, or uses RSocket to talk to other services. Oh, there's also a gateway. Where did I see that? RSocket. Where did we put that? Is that on our project? Okay. No, it's not here. There's a Dr. Tyre. This one. So you go up here. So there was an interesting. Oh, Luluki, something like this. Is that GitHub? No, I've got this wrong. There's a proxy. There's a gRPC RSocket gateway or something. Liklus, whatever this is. Oh yeah, it's on Sergey's repository. So this is is an Estonian word. It means traffic. Aha, leakless. Okay, leakless. RSocket gRPC based gateway for the event-based systems from the ones who think that Kafka is too low level. Horizontally scalable RSocket gRPC streaming gateway supports as many client languages as RSocket and gRPC do. Java, C, blah, blah, blah. Per partition, back pressure aware sources. vv.com. There you go. You can try that out as well. That's a great way to build a service that communicates both protocols and has messaging like semantics. And reactor leakless service grpc.new reactor stub. That's nice. There's some interesting opportunities, my friend. We've only begun to scratch the surface. I did a mostly still true, viable, whatever, series on videos here, right? Called when I looked at spring tips and I looked at RSocket on this. I looked at controllers. RSocket Revolution. Maybe this is the one. Yeah, this one. Watch this one. This is good. It's not great. It's fine. Nobody like died or anything like that. So it's better than nothing. But it's a whole roving tour of like RSocket and security, RSocket and Spring integration, RSocket and core Spring framework. I think I even showed the low level like RSocket was just core RSocket without any Spring support. Then I look at the controller component model and so on, right? So this is the controller component model. This is before records. Womp womp. So yeah, it gets we look at what is this? Clients, inbound adapters for RSocket and reactive programming. There's a lot of cool stuff here. Do we have a minute? Do you want to try doing the declarative interface clients? I think I want to try that. I haven't done that. Let's try that. I helped complain about it, which is not quite the same, but I did ask for help for the GraalVM stuff. I don't know if it works or not. What does that look like? If I had an interface, okay, I want a customer client, and I want an exchange message mapping customers, and the publisher of customers. So this is my ideal client, right? Is that. So how do I turn all of this into just this? I want to just inject that. And this is probably the same as before. For HTTP, you've seen me do that before. So let's try. I'll just guess. So customer client. Okay, and we're going to use the RSocket requester. Yes. Okay. We'll say RSocket service property factory. Yay. Builder dot RSocket requester. I guess we pass that in. That makes sense. Okay. And then build dot client, customer client dot class. Does that work? And then for this, I need to change this not from message map. Does it message exchange? No, it looks like I can still use message mapping. So let's try this. Let's just see if that works. So I can Command C that, paste, customer client, okay, client dot customers dot subscribe. Okay, take 3. Fingers crossed. Oh, JK. I knew I did something wrong. Unexpected method invocation. Customers. So is there not, let's see, message exchange? Or the RSocket exchange? Yeah, okay. There you go, that worked. So that worked with Java. Now, the real test. Does this work as a native image? Who knows? These are the things I like to find out live in front of lots of people. Okay, we'll recompile and build and native. It'll W native compile and build native compile client. Let's see what happens. Oh, what could go wrong? I mean, it'd be nice if this works. This is like, to me, this is like such a clear-cut win. You create the client, and then the consumer of your API just uses this interface. And it's like RPC. It's like the service exporter, like the client proxy factories of the old service exporter days. Just an amazing opportunity. Fingers crossed. Yeah, knocks on wood, exactly. Yeah, I got to knock on wood. I'm like, come on. Hey, that worked. Good stuff. So, my friends, there we go. Let's call that good. I think let's seize victory from the jaws of defeat while we can. I'm gonna call it good. It wasn't like a perfect run, but all I wanted to do was just try things out and see where they stood in March of 2023. I haven't done RSocket in probably a year. We've been a little busy, and I haven't done GRPC in a few months, and just to see all that cool stuff that Dr. Sire put together and to see how that works in native, I think it's a great time to build really, really efficient services at scale. Now, I'm glad we got to cover some of the old stuff from 20 years ago, just to kind of like set the table and so see that Spring has always been the sort of one of the easiest ways to build RPC-based services. It's just that the paradigms, the foundations, the things that we've come to demand out of building RPC-based services have evolved naturally, and so Spring has kept up with that, and you can see that here. I think we've even talked about this before, right? If you're going to build, I like REST fine enough, but there are certainly, if you're trying to build service-to-service communication within your own fairly homogeneous data center, things like gRPC might be better. And for service-to-service communication, if you want more efficiencies, more flexibility, something like RSocket or even gRPC might be better. You just don't limit yourself to just HTTP. It's not the only protocol out there, and it's not even necessarily the only one that's good for you, right? We looked at RSocket. I mentioned GraphQL. GraphQL can run over RSocket. So now you get the best of both worlds. You can write RSocket-based GraphQL-based services and conduct it over RSocket as a transport, just like you can use GraphQL over WebSockets and GraphQL over HTTP and service and event stream. So I've done videos where I talk about that. I've looked at this kind of stuff before in blogs and all that kind of stuff. So definitely find it, and I appreciate your time, my friends. Have a great Sunday. The rest of you, Sunday evening, Sunday afternoon, Sunday. It's Sunday afternoon for me. So basically, there's I don't know, another 6 or 9 hours of people who are somehow even further behind me at the moment. They're like where I am standing here. It's 1 o'clock in the afternoon on Sunday. So most of the world's already past that. But for everybody, have a great day. I appreciate you all, and I'll see you all soon. Oh, yeah, I'm glad you like the history. We've come a long way. I love that. I mean, and again, I remember the attributes. You could have these attributes in C# classes, and you just suddenly had a service, and it was like, compared to like 7 different interfaces and classes that you had to write for one EJB in Java, I felt like Microsoft was just taunting us, just teasing us, like the emperor has no clothing, Hey, you're welcome. Thanks for joining me. I'm glad we got through it. My keyboard's going to slow me down, so this is as much a chance to rekindle some of this stuff as it was to to practice on my keyboard. Hopefully it'll be better by tomorrow. Hey, everybody. All right. Have a great, great day. Bye-bye.